Oxidation reduction reactions, oxidizing and reducing agents. I'm Mr. B. In any oxidation reduction reaction, both processes occur simultaneously. Oxidation is the loss of electrons, which usually but not always result in the formation of a positive ion. Reduction is the gain of electrons, which usually but not always result in the formation of a negative ion. The loss of electrons and the gain of electrons must occur at the same time. The substance undergoing oxidation represents the reducing agent. The substance undergoing reduction represents the oxidizing agent. By definition, an agent is a force or substance that causes a change. During an oxidation-reduction reaction, one or more substances will change as a result of the change of another substance. When lithium metal reacts with chlorine gas, the chemical change is a result of agency. Reducing agents undergo oxidation. Reducing agents provide the electrons for reduction to occur. Lithium metal is a reducing agent. The electron released by lithium metal can now be used to reduce another substance. Oxidizing agents undergo reduction. Oxidizing agents will accept electrons, so oxidation can occur. Chlorine gas can be an oxidizing agent. The 2 electrons accepted by chlorine gas came from a reducing agent. 2 types of oxidation reduction reactions include the single replacement reaction and the combustion reaction. Let's begin with a single replacement reaction where magnesium metal reacts with aqueous aluminum chloride to produce aqueous magnesium chloride and aluminum metal. After writing the oxidation states, it is obvious that magnesium is oxidized. During oxidation, the oxidation number of a substance will increase. The half reaction for the oxidation of magnesium is written as follows. Mg0 produces Mg plus 2 and 2 electrons. The 2 electrons released can now go on to reduce another substance, so magnesium is the reducing agent. Aluminum cation is reduced. During a reduction, the oxidation number of a substance will decrease or is reduced. The half reaction for the reduction of aluminum cation is Al plus 3 electrons yields Al0. Aluminum cation accepts 3 electrons from magnesium metal, so oxidation can occur. So in this case, aluminum cation is the oxidizing agent. There can be no oxidation without reduction, and vice versa. In an oxidation half reaction, the electrons are always written on the product side. And in a reduction half reaction, the electrons are always written on the reactant side. When the charge is balanced, the half reactions are balanced. In the oxidation half reaction, the charge on the reactant side is 0, and the charge on the product side is plus 2 plus minus 2, which is equal to 0. In the reduction half reaction, the charge on the reactant side is plus 3 plus minus 3, which is equal to 0. And the charge on the product side is equal to 0. Multiplying the oxidation half reaction by 3 and a reduction half reaction by 2 will balance the total number of electrons lost and gained. When electrons are balanced between the 2 half reactions, the equation is balanced, where the 6 electrons produced are also consumed. And the coefficients from each half reaction can now be placed into the chemical equation. So the balanced chemical equation becomes 3Mg plus 2AlCl3 yields 3MgCl2 plus 2Al. Now for the combustion reaction. During a combustion reaction, an organic compound will react with oxygen gas to produce carbon dioxide and water. After writing in the oxidation numbers, the oxidizing and reducing agents are easily determined. Carbon is oxidized, going from an oxidation state of -4 to +4. So carbon represents the reducing agent. And oxygen is reduced, going from an oxidation state of 0 to -2. So oxygen is the oxidizing agent. This concludes my lesson on oxidizing and reducing agents. I'm Mr. B.